The slope of a line is its vertical change, also called the rise, divided by the horizontal change. Sometimes slope is referred to as gradient. You might have seen these signs on the highway or a road. They show when the road is very steep. These are all the ways to express slope. The variable m is used. Slope could be rise over run, change in y divided by change in x, delta y over delta x. The delta symbol means change in. It's that triangle there. And y2 minus y1 divided by x2 minus x1. And finally, here's a summary of all the different types of slopes, what they look like, and if they're positive, negative, 0, or undefined. Find the slope of the line that passes through the points 2, -1, and 3, 4. We're going to do this by graphing. So when you graph, always start with the origin first. Sometimes marked with a open circle. And go 2 to the right and 1 down. So there's 2, -1. And 3, 4 is 3 to the right. Remember, first do the x and then the y. Now use your ID or a straight edge to connect them. And there's the line that we have. Okay, so now we have to find the slope with rise over run. Okay, now to do that, start with one point. You can start from either one. I'm going to start from the left one. And how do I get from the left point to the right point? Well, I'm going to use dashed lines here. Okay, so I went 5 up, and then 1 to the right. So 5 up, and 1 right. Up in the coordinate plane is positive, so that's positive 5. Right in the coordinate plane is also positive, okay, because these numbers here are positive. 5 divided by 1 is 5. So there we have it. The slope of that line is 5. If you started with the left point, I'm sorry, with the right point, the higher point, you would first have to go down 5 and then 1 to the left. So let's look at that. You would go 5 down and then 1 left. All right, the coordinate plane down is negative. Okay, you can see with these numbers over here, they're negative. And left is also negative. See, left is negative. So -5 divided by -1, negative divided by negative is positive. Okay, so either way you do it, you get the same rise over run, same slope. Find the slope of the line that passes through the points 2, -1, and 3, 4. This time we're going to use the slope formula. So first, it helps a lot if you label the points. So normally this would be x and y, x and y, but we have to give them last names too. So x1, y1, x2, y2. When you use the slope formula, make sure, if you want to really be careful, this is the general setup of the slope formula. I'm using parentheses, and now I'm going to carefully substitute. So y2 was 4 minus -1, so I went in this order, and then x2 here is 3 minus 2. Okay, so I'm following the same direction as before. All right, 4 minus -1, well, keep change, change. So that becomes plus. So we end up getting 4 plus 1 is 5, divided by 1, equals 5. So our slope is 5, the same as the answer we had with rise over run. Does the slope change if you label the points differently? So we're going to experiment with the points 2, -2 and -3, -4. Just like before, I'm going to label them. So I'm going to call it x1, y1, x2, y2. It takes a little bit of practice to learn that subscript. All right, so do my setup. Okay, so I have to start with y2 minus y1. So I'm going in this direction. So that is -4 minus -2, then -3 minus 2. Okay, what do I get here? Well, same thing as before. Keep the -4, change the minus to a plus, change the -2. So I have -4 plus 2. If I owe $4 and I pay back 2, I still owe $2. -3 minus 2 is -5. And a negative divided by negative is positive. So that's 2/5. A quick way you can check if that's right is you just make a little sketch. Okay, this would be x, this would be y. And if I was to plot those 2 points, 2, -2 would be, roughly here. Oops. Sorry, dropped that in the wrong spot. And just redraw that. Okay, so 2, -2 would be roughly here, and -3, -4 would be even lower down here. And if I was to connect those, I would indeed have a positive slope. Okay, so that answer makes sense. All right, now we're going to do the same slope, but we're going to label the points differently. So this time, the -3, -4 is my x1, y1, and x2, y2. There's my formula. All right, so you always have to have that minus there. So y2 minus y1 is -2. The minus stays, -4. Okay, I went in this direction. And then 2 minus -3. 2, the minus stays, -3. Okay, let's simplify. I got 2 negatives next to each other. So -2 plus 4 is 2. 2 plus 3 is 5. Leave it like that. And if you'll notice, those are the same. So to answer our question, does the slope change if you label the points differently? That is a big no. It's like 14 exclamation points. Okay, I ran out of room. Next, calculate the slope of the line that passes through 5, -3 and 5, 4. Okay, we've been labeling, let's not change that. x1, y1, x2, y2. Okay, now good time to practice writing the slope formula. So slope is y2 minus y1 divided by x2 minus x1, and we can substitute. So first, 4 minus -3. Okay, very important, that minus is always there. That minus is always there. And then we have 5 minus 5. Okay, keep, change, flip. Oh, I meant keep, change. 4 plus 3 is 7. 5 minus 5 is 0. And now go to the calculator, type in 7 divided by 0. If your calculator didn't blow up, it's probably telling you that you can't divide by 0. So this is undefined. Okay, that slope is undefined. And if you recall from the earlier slide, if you have a vertical line, that would make sense. So if we had, let's make a quick little sketch. 5, negative 3 would be down here. 5, 4 would be here. And if you connected those, that is a vertical line. That's why it's undefined. So that is correct. The table shows the average female height at various ages. Find the rate of change in inches from age 3 to 6 for the 2012 data. So this data over here. All right, which means we're looking at the line above at age 3 and age 6. So over there. All right, we should write those ordered pairs. So at age 3, looking at this number here, it's 38.7 inches. And the other one at 6, it's 46.9 inches. And the rate of change is slope. So we're going to do exactly the same thing we've been doing before. x1, y1, x2, y2. The main difference is that now we're going to have to use units correctly. So, all right, start with y2 minus y1. So we have 46.9 minus 38.7 all divided by, so I went in this direction, I'm going in the same direction again. 6 minus 3. All right, challenge yourself and do 46.9 minus 38.7 without a calculator, or even try to do it mentally. See if you could count backwards to get the correct answer. All right, take a moment here. We could go ahead and do the easy part. 6 minus 3 is 3. And for the numerator, we have 8.2. So it's 8.2 inches in 3 years. All right. Divide that by 3 again. Try without a calculator. You get 2.733. Actually, that 3 repeats, so this does equal. But I will estimate for my answer. So it's 2.7 inches per year. Okay. Otherwise, you could write it as you could also say 2.7. So you could write it this way. Okay, all the same thing. All right, use the graph below to answer the questions. All right. First, we have what line has a positive slope? Well, if you recall, positive slope means that it's rising from left to right. So rising from left to right, because numbers always start from the left in the coordinate plane and they move right. So here would be line B. What line has an undefined slope? Well, recall from before, that's the vertical line. So line, the vertical line, vertical is the one standing up, that's line A. Which line is vertical? Is that possible that it's the same answer as before? Yes, it is. Okay. Doesn't always have to be one of each. And finally, which line has a negative slope? All right, negative slope falls from left to right. Think about if there was a skier there on line D, the skier would fall. So line D. Okay, and here's a summary of what we did before. A little hint to remember what's the horizontal line. Just think of the word horizon. So in a horizon you would have like a sunset. So horizon, horizontal, that's the one that goes left and right. Has no slope, it's flat.